Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toide online class. Today, I want to introduce integration. Integration. Of course, integration is defined as the converse of differentiation. That is, when we have, the general concept is calculus. Calculus. So under calculus, we'll be talking about differentiation and integration. Integration. So differentiation is otherwise known as differential calculus. This is differential calculus, while integration is otherwise known as integral calculus. So that is the general concept, differentiation and integration. So I have about 10 to 12 videos on differentiation. So we have actually considered differentiation in the past. So I have about 10 to 12 videos on differentiation. So today I'm starting integration, which is defined as the converse of integration, that is anti-differentiation. For instance, if we have the y dx to be equal to x raised by n, of course, this is the derivative. This is called differentiation. Like under the differentiation, we have something like, if we have y is a function of x, say s squared, then the slight change in y over slight change in x, the y ds is differentiation. Taking the derivative of this, these two will come down. We have 2x, then we subtract 1 from this, that'll be 1. That's 2, and the y dx will now be 2x. What if we know the derivative, the y dx? How do we get y back? Then we are going to integrate. So once we integrate, we are going to get it. That's why the integration is the same as anti-differentiation. That is, if I want to get y back, I'll just say I will cross multiply. So I will have dy to be equal to 2x dx. Then I will introduce integral sign. If I integrate dy, I'm going to get y. If I integrate this now, if I integrate this 2, if I integrate this 2x, it simply means that I will say 2x. I will add one. This is, we have 1 there. I will add 1 to this power. Whatever I have as this as the power here, I'm going to use it to divide. 1 plus 1 is 2. Then I will add plus c. 2 will cancel 3. At the end of the day, I will have y is equal to x squared plus c. That will be the integration of this derivative, dy dx, which is equal to 2x, will be the integration there. So let's now look at this generally. If I have generally now, if dy dx is equal to xn, then how do I find the integration of this function? I'll just say I will say dy to be equal to xn dx. So I will introduce integral sign. This is the integral sign. Whenever you have dx here, this integral sign must be there. And if you have dy, the integral sign must be there. If I integrate dy, I'm going to get y is equal to, if this is a polynomial function. I have so many, about 12 videos on differentiation. We have polynomial functions. There are so many functions. We have exponential functions, logarithmic functions, we have trigonometric functions. We have so many functions. But this is polynomial function. How do I integrate this? I'll just say x, n. Then normally when you want to integrate a polynomial function, we add 1 to this power. Then all over all over everything that we have as this power, that's n plus 1, plus arbitrary constant. It is compulsory to put arbitrary constant. So if the y dx is equal to xn, then y will now be equal to, this is what y will give us. Whenever you integrate, you must put this, where c is called the arbitrary. It's called the arbitrary constant. It's called the arbitrary constant. It is compulsory, because why do we need to add c? So if we have subsidiary conditions, we'll be able to know the actual value of that function y. So if you are given the function y, when you differentiate the function y, you get the derivative. If you are not given the derivative, when you integrate, you get the function y back. And that is what we are about to do. So this is introduction to integration. And of course, in this case now, this is our n. N cannot be equal to -1. In this, on the board, in the example we have on the board now, n cannot be equal to -1. No, this n cannot be equal to -1, because once n is equal to -1, this denominator will become 0, and this function will be undefined. So in this case now, n cannot be equal to minus 1. Please, let's note that n cannot be equal to minus 1. And whenever you integrate, we put arbitrary constants. So there are two types. This integral sign, that sign is called the integrand. This sign is called the integrand. That is, if we have y can be equal to integral f of x dx plus arbitrary constant. This integral sign is called the integrand. So we should note, let's note that is called the integral sign. Okay, so if dy dx is equal to f of x, if dy dx is equal to f of x, then y, when we integrate this is what we are going to get. So this is the integral sign. Y will be equal to this is the integration of this derivative, this integration of this derivative. Now, note that there are two types of integration. We have the indefinite integral. We have indefinite integral. Indefinite integral, like the example that I gave, where they are open. In other indefinite integral, you can have integral maybe 2x dx. So this is example under indefinite integral. It's open-ended. There's no boundary. So it is open at the lower band and upper band. Everything is open. So this is called the indefinite integral. Whenever you integrate under the indefinite integral, you must put arbitrary constant. It is compulsory.